There must be a huge element of human algorithm interaction here. I think, Grant, you mentioned the geologist predictions enter the data pipeline. I don't know if the algorithm is using that. There must also just be an element of persuasion at the other end. Whatever the algorithm produces needs to somehow have a persuasive element. And there must also be a potential for the geologists themselves to learn from whatever the algorithm is doing. So anything in that space, I would just love to hear how that all plays itself out, how you think about it, how you manage that component, how that enters your technical build, or do you view that as a separate activity independent of the technical build?
Well, I think there's a fascinating approach to this. So, from a business perspective, we had to build a model that was a system of gathering data around the world that was profitable and would improve. And so you can approach it from hey, I need the perfect data set, which is frankly impossible and of a massive scale, or you can approach it from, we're going to collect data and use it for its local insight that's valuable enough to have customers start consuming it, and then build a system that improves. And I always call it, where it gets really interesting is you can go to a 100-year-old mine site and you can have AI predicting, is this rock A or rock B? And what we do is we publish a confidence factor. And then the human goes in and says, okay, if it's under whatever X% confidence, I look at this and I decide what I think it is. And then we try to improve the model. And if you can't improve the model, chances are your differentiation between rock A and B is either incorrect or needs some refinement. And so you can elevate that whole thinking of what the actual types of rock in the deposit are. And what tends to fall out of that is really interesting things like this type of rock has most of our arsenic in it, and we've now identified it because we were trying to predict it, and we were forced to recategorize our prediction based on this super consistent, precise engine that's running beside us. And so that's where it gets really interesting, because that then foundationally changes the geological interpretation of the deposit. And not necessarily foundationally, but enough that you can clearly see the patterns emerging. And that's one thing about geoscience. There's a bit of a beauty contest element to it. If you can identify something new or identify a new mineral that is a tracer element to what you're going for, it gets really interesting on the edges.
Grant, can I just follow up? Because I just want to make sure I got the story. That seems like a super important story to understand for your entire business. You're sort of saying, rather than the algorithm coming in and saying, look, I've made my prediction, here's the prediction, you're entering at a more granular level in workflow and saying, look, you as a geologist are in the business of identifying these things. Let us just semi-automate that for you, which you're happy to have do. Then they come in and they see these edge cases, but those edge cases then draw them like, wait, why is this thing always coming in an edge case? Oh, I learned something from this edge case. So there's sort of insight being had already, partly because you didn't come in at the top of the funnel. You came in kind of at the bottom at what looked to be an automation activity, but it was kind of an automation activity that became an interesting discovery activity. I just want to make sure I got the story right.
Yeah, that nailed it. So you have this data flow from the interpreters, and they're putting it against a prediction. And that prediction might be great, it might be okay, but the art of doing that leads you to all the edge cases being way more interesting, and then helps you refine the problem on a holistic level, if that makes sense.